All Nabila, Neha, Maha,
Yes.
Nabiha, you join your class only. Okay, your batch only. You had your exam today, Nabiha?
Yeah, ma'am, I had chemistry today.
Yes, physics will be on the next Sunday, right?
Yeah, ma'am. Yeah, ma'am.
So, till gravitation, it is coming. Solids is not coming.
Solids is also coming, ma'am.
Solids is also coming. Okay, then okay, solids. I'll be starting with solids today. So I'll have to discuss the assignments also. Class yesterday we just discussed. So I'm just discussing what all things we had. So I think you all didn't write anything yesterday. This whole Kepler's
Yeah.
laws writing. You did.
No, we didn't write.
Let me just quickly revise it. Then you can write. First law was, and in your test, this entire chapter is coming. Not for you, Nabiha. In your batch, rotational motion is coming, center of mass. In this, it is coming. So first law is that we discussed that the orbit of the path of the planets in which they move, or the satellite, is not a circular path, it's ellipsoid. So in ellipsoid there are two foci which are present, in which sun lies in any one of the foci. When the planet is nearer to the sun, we say that point is known as perihelion, and the opposite one, which is the greater one, is known as aphelion. Okay, the axis, the greater axis which crosses it, which means greater in the diameter and length, that is known as the major axis. Half of it will be semi-major. Similarly, the shorter axis is known as the minor axis, and we say semi-minor axis. These are the things which you should know. Okay. And second was regarding the aerial velocity. Aerial velocity means whatever is the area swept. If you take, see, actually the area is not swept because the bodies are just moving in the circular or ellipsoid motion. They are not moving within the space. But if, let's say, at this P1 point, the planet was present. Then at P2 point, the planet was present. And then we take the area subtended at the sun. That is your delta A1, means change in the area. Okay. I'll write this also. This is change in the area, and delta T is the change in the time, means time duration. Okay, aerial velocity remains constant. Aerial velocity basically means rate of change of area, how much area is covered. So the whole ratio will be the same. Like if I to take another 2 points, like P3 where the planet was there, P4 where the planet was there, this area swept, the ratio will be constant. How will the ratio be constant? Let's say here the area is less, A1 is less, so the T1 will be greater. If here A2 is greater, so here the time will be very less. Okay, like this. So this is how, when you cross multiply all of these, the ratio remains the same. Last was law of time period. You have a semi-major axis, that is A, which is technically the radius of the ellipsoid. This is the radius of the elliptical orbit. This also you can take, simply radius also you can take. I'll make you practice some numericals also on this. One question we'll do. So t square means square of time period. When we talk about t square, this means this is the square of the time period. Square of the time period is directly proportional to cube of the radius. Okay, so t square is equal to k a cube. You should remember, mostly the questions are in ratio. So the k constant will be cut. So these are the three Kepler's law which you should remember. Okay, please write it. Then one numerical, let's practice, and then I'll come to the assignments of rotation motion. Okay, let us discuss. See, I was going through your assignments once again. Only Neha and Harsa have submitted all the assignments of this chapter. Most of the students, Maha, you have shared one of the starting center of masses one. Few
No,
students
I
have rejected it.
shared didn't I didn't share one assignment.
Center of
The
mass one.
last one.
The rest of it you have submitted. No, Maha. What?
I
Your voice is
wasn't,
cracking.
Mom, I wasn't there for most of this chapter. So that's why I haven't completed the assignments as I'll come.
Yes. Yes,
I'll
I
submit.
shared. Maha, you have shared one, only one, no?
From which chapter are you talking about? This chapter, right? Gravity.
No, not gravitation. Gravitation, I'm not talking. Rotational motion. You shared one, the rest of the assignments I have not received. You have not shared, no, others. The complete chapter. Rotational system of particles and rotational motion. Nabila, your assignments also? All are not completed? Chedim?
Yes, no, I shared it.
Ikra, what about you? Not a single assignment anywhere. None of the chapters. Only Neha and Hafsa have been preparing the assignments properly for the. See, now gravitation is over, class. At least try to share. But I'll discuss the rotational one today itself. See, Ikra, what's your reason? Why don't you submit any homework? Open the cameras, all of you. See, this says that time period of a planet X around the sun is 100 years. You have to calculate semi-major axis. Okay. Yeah, Ikra, I was asking, what about your homework? At least one or two assignments should have been received.
Yes, no, I will try to start submitting.
At least share few rotational chapters, share few assignments of rotational chapter, because now the next class will be on Saturday directly.
Yes, ma'am.
Few instructions are fixed. Today also only Neha came and opened her video. You have to switch on the videos. You have to submit the assignments. Rotational motion, none of you were submitting the assignments while the chapter was going on. So we couldn't discuss any of it. Now, since the chapter is over and the next chapter is also over, that's why we can't delay it further. Okay. So, anyways, all of you, not only just Ikra, those who have assignments pending, share it. So time period of planet X around the sun is 100 years. So T of this planet X is given as 100 years. You have to calculate the semi-major axis of this planet. Now nothing else is given. And K also we don't know. So I told you use this always for the ratio part because your constants will be cancelled. Right? In order to cancel the constant terms, try to use this. So what you do here, you take the time period of Earth because this is known to us. Right? If this says time period of some planet X is 100 years, we know what's the time period of Earth, right? Do we know or not? At least Earth is known to us, so we'll always pick up things for Earth. Okay. And similarly, here also the separation same major axis of Earth is what basically. See, this is 100 years. This is how much? Class, what is this? Yes. How much
365.
then? Yes, 65 days. Yes, that is how much? 1 year? Because this is also in years, no? 1 year. Because we are talking about, this is not rotation that we'll refer to 24 hours. That is 1 year. We are going to take 1 year, okay? Now, this I'll tell you. See, this is not your radius of the earth, okay? When we talk about the radius of the earth, that value we just is present, and okay, just a minute then. Voice is taking. Now is it better? Are you able to hear, all of you?
Yeah, ma'am.
Okay. I was saying we don't take the radius of the earth because radius of the earth is just limited to radius. See, you have the sun here and you have the earth here. So radius of the earth will be for the earth itself. No, you can't take this separation. So if a person starts moving from earth and reaches the sun, that entire distance is measured in astronomical unit. So instead of taking the radius, don't take the radius of earth here because this is the semi-major axis. Means you are taking the separation from the sun. So that is one astronomical unit, which is 1.496, but 1.5 le lena, into 10 to the power 11 meters. Okay. Now see, we have all the values. We can take an answer. Will be very simple for this question. TE square equal to K into A divided by TX square by K AX cube. So K will be cancelled. Now see, time period of Earth is one only, one square. This is 100, so 100 square equal to. This is 1.5 into 10 to the power 11 cube divided by AX cube is missing. Okay. So from here, AX will be equal to 1.5 into 10 to the power 11 by 100 to the power 2 by 3. Solve this, see what's the final answer coming. Means take the square first and then take the cube root. Almost 1.5 something, a little less than that will come. Okay.
Your voice is stuck.
Again, so just note it for meanwhile I'll see. Done? Everyone?
I don't understand how you got the, like, do you not cross multiply?
We'll cross multiply. AX will be here. Oh, this will be multiplied.
By
Yes.
cross multiplication, I got 15 into 10 raised to 14 raised to the power
This
of 1
will
by
be
3.
multiplied. This goes here, 100. I divided it. This will be 100. This was what? This was cube. This is also cube. This was squared, no? Yes. This, did you all do?
Yes.
I by mistake wrote the other one. What is the answer coming?
15 into 10 raised to 14 whole raised to the power 1 by 3.
Okay. So this, if you write it as 150, 1.5. No, if you write it as 150, then 10 to the power 13. Okay, you can leave the answer like this because this is not divisible by 3, no? 14. Or you can make it 1500 and then write it as 12. That will be divided then. Okay. All right, let me discuss the assignments now. Then let's start with solids. Okay, this was the homework. So, since few of you only have submitted, Neha, first question you did it fine. Second question you have both had a trouble in. See, this says that a star of mass twice the solar mass and radius 10 to the power 6 kilometer rotates about its axis with angular speed of 10 to the power minus 6 radian per second. Okay, so angular speed is there. What is the angular speed of the star when it collapses? Solar mass is given to us, radius is given to us. Speed is no, one speed is given. Now look what we'll do. This is basically when you have the speed, when you have the radius and mass. Try to think of the conservation of the angular momentum. Okay, in conservation of angular momentum, the I1 omega 1 is equal to I2 omega 2, especially Neha. Okay. Because I think you marked and you said doubt in this question. So basically we know this is a star and other is solar mass. Both are what? Complete solid spheres. So moment of inertia, use this one. 2 by 5 mr square, this one. Okay. So mr1 square for I1 and similarly I2 will have 2 by 5 mr2 square. In fact, their masses will also be different. So just put it here, 2 by 5 m1 r1 square into omega 1 is equal to 2 by 5 m2 r2 omega 2. Look, what all things we have. Stars mass is twice. So one, if this is m, this will be 2m. m1 will be equal to 2m if its mass is m. Okay, radius is given. Radius we have. Both the radii are given. This speed is also given. One speed is missing. Now will you be able to calculate? Got it? Okay.
Yes, ma'am.
Quickly write down this. Others also. And then share. And the next one I'll discuss then. Done?
So I'm keeping my camera on because I'm using mobile data for connection. So it will.
Okay, no problem. Ready? All of you? Can we move further?
Yes.
Okay, yes, Neha, in the second question you had it out. I in fact wrote it in your assignment also that in our class notes we have done a question where two knives we have taken. There is one capital G. This class you have done a question like this. Okay, I think Neha wasn't there. Neha, when you came, did you do this chapter here in this batch?
No, I had missed some classes, so
You may,
those
okay,
homeworks
yeah, you
also I
were
had done.
absent. Yes, yes, yes. One or two, when your exam was there. Just take the class notes. You one this question. Let me show you in the from the class notes only. Okay, then you can take the screenshot from there. You'll be able to understand. Then in this question also see the trouble that you faced was how many accidents. In two questions I have seen you are facing the same problem with how many revolutions. You're having a problem with the number of revolutions, right? See Neha, number of revolutions will be given by theta by 2 pi r. Okay, use this. In one of the questions also I saw that other parts were correct and you missed on this. Okay, so use this, you'll be able to get the answer for the number. And this also same thing. How many revolutions does the wheel make? Okay, in this question also, Neha, you had a trouble with. See, this was also done in the class itself. Okay, I think you missed a class where we have taken the circular portion out. The remaining portion was m by 4, and then we took the center of mass of the system. This also I'll show you. Okay, I think you must have missed it because this was also from the class notes itself. And in this, nobody I think had trouble in. I was asking Maha, did you do this assignment? Maha, this was the starting assignment. Okay, Maha is there. All right. So this I think all of you were able to do properly. So these were the assignments from the previous chapter. Few questions I have given, two questions, three questions. At least do those. Those who have not attempted, those questions are simple. Most of the things you'll find in the class itself. Okay. And Neha, what all things did you miss? Do watch the video lectures also, Neha. Okay, because otherwise you'll trouble with the portion that is completed. I'll show you that disk question and all. Wait. This one. This you, I think, have not attended, Neha. Otherwise, this is the same question. Okay. Take the screenshot of this. Hope done, Neha.
Yes, ma'am.
Okay. Now, class, I'll start with solids chapter. So, second book. First book is over. So all those students who have their exam also, Nabiha, you can attempt this. That's a question of NCRT, that knife one also you'll be able to get. Just do watch the videos, Neha. If you want, we can share the playlist with you. Okay, whatever classes have been missed. Now, class, coming to book 2. Book 1, please revise, and in the next class, I hope we'll be able to practice all the assignments of gravitation chapter. Okay? So see, basically this unit is about the properties of bulk properties of matter. Okay? The properties of bulk matter, in which 2 chapters are there. Mechanical properties of solids. Now, when I say solids, these are those solids that we studied in the rotational motion, rigid bodies, okay? Solids. Then second, you have a chapter, mechanical properties of fluids. Mechanical properties of fluids. Now see, out of these, solids is a very short, easy chapter. Fluids is a very vast chapter because there are 2 parts in fluids. You have hydrostatics, you have hydrodynamics, one in which the fluid is at rest, one in which fluid flows. So fluids is a lengthy chapter, a little tough chapter also. So we'll give a lot of time to fluids chapter from the second book. First chapter is solid. It's a very easy chapter. Just attend the classes. In the class only you will be able to remember most of the things. And those who have their assignments pending assignments is to the solids one also. Okay, don't leave this chapter. It's a very small and easiest chapter of the entire 11th part. Of course, units and measurements were also an easy portion. That was also an easy part, units and dimensions chapter. Solids is also a very easy chapter, very easy formula based chapter. So because it's just about the solids and fluids, you have both air is also included and liquid is also included. While in solids, we just talk about the solids. Few things are there. I'm starting with this chapter. Just understand through this example. Let's say I hope I am audible and everybody is hearing. I'm starting with this chapter. Okay. See, let's say I have a rod. This is a rod and I have hung one of its end and the other end is fixed, free. This is the free end, other end is over the rigid part. Let's say the length of this rod is some L and let me take some value. Let's say this is 10 meters. Okay, there's a rod whose length is 10 meters. This complete length is 10 meters. Now, L will be the original length of the rod. I have taken a steel rod. Let's say this is a steel rod and this is hung over a rigid body and the other end is free. Now what I do, I connect some mass with this. Let's say I have put. As soon as I connect mass, we definitely know mg will be acting. Okay. What was the length of the rod? Length of the rod was 10 meters. But now what I have done, I have connected a force. M, weight body I have connected over its free end. Now I'll notice that there is a little elongation in the wire. See, if you see this portion, this is the extra portion. Let's say delta L, the change in the length is coming. Let's say this is 0.1 meter. So total length of the rod will now become 10.1 meters. This complete length of the rod will be 10.1 meters. Because the change that is coming is delta L. So let's say this is L dash. L dash is the new length of the rod, that is 10.1 meters. It is occurring why? Because there is a connection of this mass, a block of mass M over here. Okay? And reason is that this is exerting a force mg downward. Now what I do? I have seen this observation, okay, because obviously I've connected a mass towards its free edge. A little elongation of the wire is observed, 0.1 meter, and the original length was 10 meters. Now it is 10.1 meters. Now what I'll see? I will remove this block. What I'll observe? I'll see the body is coming back to 10 meter. This is my observation. First, understand what has happened over here. Then I'll discuss the things again. I had a steel rod, okay? One edge of the steel rod, I fixed it above, okay? One edge is fixed. Below end is freely available. So what I do in this freely available portion, I connect a mass M. Initially, I measure it, it is 10 meters. Now I connect a block of mass M towards the free end. Obviously, mg, that is the gravitational force, will be pulling it down. Now, what I notice, as soon as I connect this block, the rod elongates a bit. A certain small change in its length is observed, that is 0.1 meters. The length of the rod also increases up to 10.1 meters. Okay, that is L dash, which is the new length now. But what do I notice? As soon as I remove this, the length becomes back to 10 meters, which was its original length. So we have three lengths over here. L, original length, L dash, new length, delta L, change in length. Am I clear till here?
Yes, ma'am.
It would be change in spring only, right?
In spring only, no? Steel also?
Okay.
Okay. In fact, you have a question also that steel is more elastic than rubber. There's a very famous question of your NCRT that comes. So your perception will change when you will understand the properties. If I say steel and rubber, I give you right now, and I ask you which is more elastic. Obviously, you will think rubber, but actually steel is more elastic than rubber because of the properties. So that these things, so don't keep in mind that only spring elongates and all, rods elongate, because these are all material dependent. That's what we are studying, solids, the properties of solids. And see, chapter's name is mechanical properties. Mechanical property means change in length, change in volume, change in shape, all these external changes that are coming due to the internal properties. That is why the chapter's name is mechanical properties of solids. Next chapter is mechanical properties of fluids. What kind of other properties? The next chapter will be thermal properties of matter. Matter means all solids, fluids together. So then we'll be talking about just the thermal properties, means heat related properties. Right now we're talking about the mechanical properties, all the changes in length and all, volume, tension, everything. Okay. So, class, understand these forces, these kind of forces like mg or any other force. This was just an example. This is not your entire solids which is based on. I am just giving one example through the help of a steel rod. These kind of forces which produce a change. Change can be the change in the length, the change can be change in the volume, change in the shape, any mechanical change, because as I said, we are referring to mechanical properties. These forces are known as deforming forces. Okay, these forces are known as the deforming forces. Deforming forces means they will produce a change. Like here, the change was in the length. There could have been a change in the volume. There could have been a change in its shape if other object was there. So deforming forces produce a change. Now see, what are we studying? This ability of the body to elongate, like steel could be elongated because of presence of deforming force. This property is known as elasticity. Okay, this property is termed as elasticity, that the body has the ability to change. Okay, so we will say the bodies are elastic body. Now, how to identify whether a body is actually elastic or not? Like, is it really elastic? You can check even after the removal of the deforming force, the body came back to its original length. It means it is elastic. Elasticity means, the term elasticity means that the body has the tendency to regain its shape back, whatever its original shape was. See, we started with 10 meters. Now we are here back to this 10 meters, right? We are back to this 10 meters. Here we have the tendency of the body to regain its shape after the removal of the deforming force. Till the time you have the deforming force, definitely a deformation will be produced. Okay. So that's what kind we say elasticity, elastic bodies. And in fact, here also we have two kinds of elastic bodies, if I refer. One is the term perfectly elastic bodies. Perfectly elastic body. A perfectly elastic body means it can regain its exact shape, size, volume back after the removal of the deforming force. That is what is a perfectly elastic body. Like steel, steel can regain. Rubber can regain. Rubber band, stretch it, it becomes back to its shape. At least we all are familiar with rubber bands, right? So second is perfectly inelastic body. Perfectly inelastic body means body can be deformed on deforming force, but on removal of this deforming force, it won't come back to its original shape. Like clay, elongate a clay, leave it. Will it come back to its shape? It doesn't. That's why we play with it. We matlab kids, they play with it, right? So when this, what kind of body will be clay? It is a perfectly inelastic, or a better term for it is plastic. Plastic means it won't be able to regain its exact shape. Okay, wax is an example. Okay, let's come to the definitions. Elastic property, the tendency of the solid to regain its shape and size after removing of the deforming force. Okay, this is important. After removal of the deforming force, then we will be able to understand whether it is elastic or plastic. Then we have deforming force, force which produces a change in configuration. When I say configuration, it can be length, it can be volume, it can be shape. Okay. Then what is elasticity? Elastic property is only elasticity. It's a property of the body by virtue of which it tends to regain its original shape and size when deforming force is removed. Now, two kinds: perfectly elastic body. Perfectly elastic body, a body which regains its exact original shape and size immediately after the removal of deforming force. That is known as a perfectly elastic body. Like quartz, phosphor, bronze. These are all chemistry solid objects which you must have heard of. So what is perfectly inelastic? It does not have the tendency to regain its original shape and size even after the removal of the slightest deforming force. That is known as perfectly inelastic, or you can say plastic body also. Like wet clay, paraffin, wax, they do not take up their original shape. Here quartz and phosphor, bronze are there. पहले बताओ, यहाँ तक समझ आया?
Yeah, mom.
Have all of you understood?
Yes.
Yes, ma'am.
Yes, mom.
Right? Done, class?
No, ma'am.
Now is it done?
Yeah,
Yeah.
ma'am.
Okay, the rest of it, I'll continue it in the next class now. Okay? All right, then. Thank you. Okay, bye. Take care.
Thank you, ma'am.